just want to say before I continue with derivatives, this is the rule, the first rule of derivatives, start with constants, right? Why do we find derivatives? Well, derivative, let's say you have a function y is equal to 3x plus 3x squared plus 2x plus 7. That would be a parabola on a graph, right? So you have a graph like this, and they tell you what is the tangent of this line. What is the tangent? What is the point? What is the slope of the line then? You can't find a slope of a curve because it's a curve. You can't take 2 points because the points. How can you find the slope of a curve? Think about it. It's a slope of a curve. A slope is a straight line. By definition, the slope of a line is a straight line. So what you do is you find 2 points on the line. When you get 0. So you find the limit of this point as x approaches 0. So when you find the limit x approaches 0, that limit you pick points on the graph, and you find a equation that allows you to find any point on the graph based on that equation. So in this case, derivative, let's say the derivative works out to be derivative of x of this function works out to be, let's say, 2x plus 2 sid. So what you can do is you plug this function, you plug any value of x into this function, and you'll find the point, the limit at any point on the graph, right? So if you plug 2x plus 3, the limit on x approaches 2x, that's the slope on the point of the graph of this. So when you plug this 2x, this point 2x plus 3, you find the y coordinate, this graph of any point on the graph. You find the limit of this point using this function. So what this equation gives you, it gives you the point on the slope of the graph at any point. So if you want to find the slope of the line when x equal to 4, negative 4, you plug negative 4 into the equation, you'll get negative 4 by 2 is negative 8 plus 2 is equal to negative 6. So the slope on the graph as x approaches, the point on the slope on the graph as x approaches as x negative 4 is negative 6. And you can tell, and it makes sense because the graph going this way. Now the equation of the line, you could plot the slope into the graph, negative 6 and x and y values, and you plot that, and you get this line here. So that's the whole idea of finding derivatives, is to find this point on the graph that satisfies any point on the graph. Find the slope at any point on the graph, right? So now we're going to find derivatives in different ways. Instead of having to do the whole equation of taking x and taking delta x, instead of doing all of that, there are certain things you can do, certain rules you can follow that can find this much quicker. That's what we deal with. So rule number 1 is the constant rule, and the constant rule states that when if you have the constant, say I have 2, say x is equal to 2, right? The function x is equal to 2. What is this function? That means y is equal to 2. So any value of x, y would always be equal to 2, right? So what's the slope of that line? Well, there is no slope. If you can tell, look at the graph, there is no slope. A slope is like this or like this. So the slope is actually equal to 0. So what they're saying is the derivative of this of a constant, which is 2, is equal to 0. So the general formula is the derivative of a constant is equal to 0. So f of x is equal to 3. The derivative of 3 is equal to 0. So now we're going on to the power rule. The power rule states that if you have a function x raised to a power, then the derivative so you have x raised to a power, so the derivative of x raised to a power is equal to nx n minus n, where you put the n, bring the n here, and minus n minus 1. Right. So let's do this example. So we have, it's in the form 4x to the third. If there's no addition, there's nothing. This is just one term. You can't take the 4 out here. You can't do that. This 4 is connected to this x. This 4 is 4x to the third. This means that this whole thing is 4x. And so it's this is what do you call it? This is a product. Right? This is a product. So you have to identify that one time, that this is a product. So the rule states that to find the derivative of 4x minus 3 is bring down the 3 here. So you get 4 by 3, and then you take 3 and minus 1 from it. So 3 minus 1. Right, so you get a derivative is equal to, then you multiply 4. My 4 by 3 is 12. X 3 minus 1 is 2. So that's it. Derivative of y, since it's a y function, and then the derivative is, you can write like this, is equal to, in this case you write it as y prime is equal to 12x squared. So let's look at this example. F of x is equal to 4 by the square root of x. 4 by the square root of x. So this, what kind of function is this? You might think it's a multiplication. This is one term. This is 4 to the power of x. Now, this term here, it can actually be written in the product form, in the power form. This is the power form we're dealing with. This is not a product form, so we're dealing with the power form. This is called a power rule. We're dealing with the power rule. Power rule means that something raised to a power. So can we make this raised to a power? Well, this can be rewritten as 4x, this is square root, so this is 1 over 2. The 1 always goes, the 2 always got at the bottom, the 1 is always here. So when you bring the 2 over, the 2 goes at the bottom. You don't bring the 2 on top. So you have to be careful. The 2 doesn't go on the bottom, the squared. No, the 2 goes at the bottom. So we get 4x. Now we have 4x raised to a power. So anything raised to a power could follow the power rule. This is one term here, so this follows the power rule. Means this is 4x to a power. So you find the derivative using the power rule. So the power rule says that you bring this term down, and then you take the term that was there and you minus 1 from it. Right, so we get 2x, this one is cancel, get 2. A half minus 1. Well, you can multiply this by 2, this by 3, a half minus 2 over 2. 1 minus 2 is minus 1 over 2, so you get minus a half. So the answer is 2x minus, okay, you get this. This answer is right, but if you don't want to write it and make the power negative, because it's harder to work with a negative power, you could also rewrite this as 2. This whole thing is connected. You can't just bring along the half. So you could leave the 2 on top. You could actually leave the 2 on top, and you could bring the x to the bottom, because this can be 2 by x. So you can separate this. So you can separate that if you want. This is like 2 by 1x. So you bring the x